Tired of your old kitchen or bathroom? Upgrade to the home of your dreams with Manny and Courtney from CMK Construction. CMK Construction is Tampa's award-winning kitchen and bath leader for over 20 years. Right now, save $3,000 on a new kitchen and $2,000 on a new bathroom. And take advantage of our no money down and no interest financing until 2026. Imagine, design, build.
Streaming from the Tampa Bay 28 Weather Center in Studio A. This is Dennis Phillips Live Plus. Brought to you by CMK Construction, crafting Tampa's most exquisite bathrooms and kitchens.
Hey there, everybody. Welcome to tonight's edition of Dennis Phillips Live. Appreciate you stopping by. Live on the spot, 66.1. The official broadcast home of the Tampa Bay Lightning. When the Bolts are off on weeknights, we are here, always out there on streaming. And tonight, we're going to get a little sciencey. I'm going to tell you flat out right now, we're going to get a little, maybe even a lot sciencey, and it all stems from what happened last night. Because when we had DPL last night, I did not mention, and I did not mention intentionally, that there was going to be a Northern Light and an Aurora Borealis event for the northern sections of the country and in Canada, because I didn't think there was any way in the world we were going to be able to see it here, which is normally the way it works. That is not the way it worked last night. So I start getting messages all over the place on Facebook, text messages, everybody saying, what the heck is going on? Why are we seeing all these lights in the sky? And they're sending pictures. And I couldn't believe it. I'm like, whoa, we're actually seeing northern lights in our area. Now, there is a reason for that, but I'm not going to begin to describe why it happened. I do know why, but not nearly to the extent that our special guests are going to be. So normally, there's a bunch of tomfoolery and shenanigans when we start DPL, but oh, no. Tonight, we're getting sciencey. We're going to get right into it. And we're going to go ahead and answer all your questions. So if you're watching on TV right now, you can ask questions on our stream. I always suggest multi-platform viewing. So you can watch TV on one side, log into my Facebook page or Instagram on the other side, and ask your questions, because you have got some super smart people here, and they are joining us right now. We have Dr. Alex McCormick from USF. How you doing, Alex?
Pretty good, thanks, Dennis.
And we have Dr. McKenna Wood, who is the new director of the planetarium at MOSI. So I figured these would be the best people to talk about why in the world we were able to see the aurora last night. So, I mean, McKenna, let's go ahead and just start here. So you're new to the area. So we were just talking earlier, you're from the Northeast and you took over the director's position of the planetarium. Well, first of all, I guess for new folks, explain what a planetarium is at MOSI and how they can take part and enjoy that as well, before we even get into why we're here in the first place.
Yeah, so a planetarium, we have the planetarium, which is indoor simulation of the night sky that you can see. We have this massive dome that simulates the night sky, and it's really great because, we can't always see the night sky, not every night. Sometimes it's cloudy, and also here in Tampa, we have a lot of light pollution. So in the planetarium, we can turn off all the light pollution, we can turn off all the clouds, we can make it so that we can really see the sky in all of its glory and all of the cool, awesome stuff that we can see in the sky. And we can also, with our new planetarium, it's basically a simulation of the entire universe, right? So we can fly around, we can see what the solar system looks like from above, we can see what the sky would look like from one of the moons of Jupiter. We can do all sorts of really cool, fun science stuff and a lot of really great astronomy visualizations in the planetarium. And it's really, really great because the new MOSI planetarium, the brand new Saunders planetarium, is the second largest planetarium in the country. So it is a fantastic way to get to see the sky, even on those cloudy nights, even in the middle of the day, there in our planetarium.
Well, last night was not a cloudy night. It was a clear night. And Alex, we saw something that, I don't know about you, were you expecting what happened last night? Because we could see the Aurora Borealis. And that, I guess my question to you is, first of all, what is the Aurora Borealis? Where does it come from? And everybody's already asking, are we going to be able to see it again tonight?
Well, to answer your first question, I was not expecting it at all.
Neither was I.
Because generally, as you said, we don't usually see this in Florida. It's not something that typically gets this far south. And there's a reason for that, which we can get into. But to answer your last question, then I'll come back to what it is. I'm not sure. I can't give you a prediction for tonight, unfortunately. I did take a look at the Space Weather Prediction Center, which is based out of Boulder, Colorado. And you've shared some of that information from them on your social media, which is really good. That's part of the National Oceanic and Atmospheric Administration, which does the National Weather Service, amongst other things. And they monitor space weather. And so I've looked at some of the things that they've shown over the course of the past couple of days to see how there's been some activity in space in terms of the space weather that suggests that there's a higher likelihood that we would see an aurora today and yesterday at nighttime, as long as it's not cloudy, right?
Right,
you need
and
a
it's
nice,
not.
Clear
so the weather cooperated.
Right,
But
so that's always a concern for astronomers. We're always worried
Sure.
about clouds because clouds come in, you can't do your work with, at least with telescopes that operate in the part of the spectrum that we can see. And that's part of what is, what we're seeing with the aurora. So an aurora is really, it's charged particles from the sun colliding with Earth's atmosphere. And that's what causes the glow in the sky. And so there's a number of different aspects to that, which we can get into. But when you see that glow in the sky, what you're seeing particles that were launched from the surface of the sun and flying through space, getting to us in, depending on how fast they were going, maybe 15, 16 hours, maybe up to a few days. And then they reach the Earth, and then they collide with the atmosphere and cause the atmosphere, the molecules and the atoms in the atmosphere to glow. And it works a lot like a neon lamp, right? So when you put a voltage, you attach a battery or you plug in your neon lamp, you get light that is emitted from that neon lamp. And the light, and sometimes other gases inside those lamps to produce different colors. The colors that you get are dependent on the composition of what's in that neon lamp. If it's neon, you see kind of an orangish color. If it's a different gas in that lamp, you'll see a different color. And that's basically what's responsible for the different colors that we see in the aurora. The fact that there are different molecules and then sometimes atoms in the atmosphere that are being hit by these usually electrons that are flying through space from the sun.
And talking about, I was going to say, talking about different spheres is, and that's exactly what happens, because when you have different parts of the atmosphere, whether it's the troposphere, whether, whichever sphere you're talking about, they're comprised of different chemicals. So I'm assuming that has something to do with the colors in which they're interacting with.
Absolutely. So I will defer to you actually on the composition of different layers of the atmosphere. But generally, the atmosphere is more dense when we're getting closer to the ground. So there's more stuff packed into a smaller volume when we're close to the ground. And then as you go up, just like if you're climbing a mountain, you might, very tall mountain, you might need some oxygen, right? The atmosphere gets thinner and thinner. And so at different densities, you have different interactions. And then also because of the different temperatures at different levels as well, you sometimes have molecules at lower temperatures, and then maybe those molecules break into atoms as you get closer and closer to space in some cases. But again, I'm going to defer to you about the composition of the atmosphere at different layers.
And I was telling everybody we were going to get sciencey tonight, and we have gotten sciencey. I'm having flashbacks of my college level physics, and let me tell you, they're not necessarily always good flashbacks. But I will ask either Alex or McKenna, whichever you feel comfortable answering. I mean, the big question we get is, okay, so if it's able to be seen out there tonight, where do we go, what time, and in what direction do we look?
I'm gonna let McKenna take that one. Go for it.
Yeah, so if you can see it from tonight here in Tampa, which, we have to get kind of lucky to be able to see it from here in Tampa because we're so far south. You want to go as far north as you could get, right? The further north you can get, the better your chances are of seeing it. You want to look mostly to the north. And if you can get to the darkest place that you can find, the place the furthest from any artificial lights or anything like that, that's going to give you your best chances as well. Something that is really cool about northern lights is that even when you can't see them with your eyes, sometimes you can see them with your camera on your phone. So if you can't get out to like a dark spot and are looking up and you can't see anything with your eyes, try taking out your phone and taking a look with the camera on your phone. And especially down here, where we might not be able to see it with our eyes, there's a much better chance that you're going to be able to see that red glow with your phone.
That is really cool. And a lot of the pictures that I got yesterday of the Dunedin Causeway, Tarpon Springs, bright red. I didn't see a lot of the other colors, but I definitely saw a ton of red in the pictures. So that's an interesting question. Maybe the pictures are more vivid than what your naked eye can see?
Yeah, definitely. Did you want to say something, Dr. McCormick?
No, go ahead. All yours.
Yeah, so definitely our cameras can see a little bit. They're a little bit more sensitive to the light from the auroras than our eyes are. And, exposing over a longer period of time can let them get more light in as well. So they can see those colors, that red glow, all of those different colors that we can't see with our eyes better than we could see with our eyes.
Interesting. All right, well, we're going to take a break. We'll be back in 90 seconds. And again, keep sending your questions on here. I will pose the questions to the experts, and we will, of course, talk about the upcoming weekend weather as well as Dennis Phillips Live continues. Okay, we are in a break, but we are still hot on streaming and social. That's a really interesting tip. I did not know that you could, I heard people say that they were seeing things with their phones, but I didn't realize that you could actually see it better. That's really interesting. McKenna, were you expecting to be able to see it?
I was not.
Did you see it?
No, I didn't.
I didn't either.
Yeah, I didn't get a chance either last night to try to take a look. Again, I didn't expect it, and that we can talk more about that. The part of the reason why you don't expect it this far south is because those charged particles that hit the atmosphere, they are funneled towards locations on the Earth where there are magnetic poles. So just like, you have a refrigerator magnet that you put on your refrigerator, right? There's two sides to that. Now, both sides of your refrigerator magnet will be attracted to your refrigerator because that's a ferromagnetic material, and it doesn't matter if it's north or south. But the Earth also has a north and a south pole to it, and in terms of a magnetic north and a magnetic south. Now, it's a little bit weird because the geographic north is actually a magnetic south right now.
We're back in 10, just letting you know.
Sure.
And, okay, so yeah, we'll jump on that back in 3,
No problem.
2, 1. Welcome back to Dennis Phillips Live. We are here with Dr. Alex McCormick from USF and Dr. McKenna Wood, new director of the planetarium at MOSI. And the question I keep getting from everybody is, what is the best time to look? And what's interesting about this is different from an eclipse or from something when people have a specific time to go out. Like, we know when there's going to be a total solar eclipse, and we know when there's going to be a lunar eclipse. And that's something that we can put in our calendars and know. But with this, we don't know when these explosions will occur off the sun's surface. And when they do, you think tracking the weather is hard in Tampa? Imagine trying to track the weather or tracking a geomagnetic storm through space from the sun to the earth and determining when and where that will actually interact with the atmosphere. So I thought my job's hard sometimes. That is about as hard as it gets. So I guess I had read, and correct me if I'm wrong, y'all, I had read that the one of the peak explosions, or whatever you want to call it, was actually this afternoon when it arrived. So if that's the case, we would not have been able to see that because it was during the day. Is that correct?
Yeah, I think there was some information on the Space Weather Prediction Center about the peak being during the day. Now, we're not going to be able to see it during the day because even though the effect is still there, you still have the particles hitting the atmosphere. During the daytime, the sun is so bright and it's scattering off of the nitrogen in the atmosphere, which is causing the sky to be blue, right? Or appear to be blue. And that's going to completely wipe out the faint aurora. So you're not going to be able to see it during the day, just like you can't see stars during the day. The stars are still there during the day. It's just that the sun's so bright it blots everything else out. It's like trying to, pick out a little tiny, flickering light right next to a giant, a giant floodlight from, Ray J or something like that from the stadium, from the football stadium or from somewhere else, right? You're not going to be able to see a little firefly next to the the floodlights of the football stadium. So
well, people are asking me if you can see it tonight, and I don't know about y'all, but I have not seen any pictures or reports that it has been visible anywhere in Florida so far. Have you?
I have not. So I noticed, on some of the data that they shared on that Space Weather Prediction Center showed that there was maybe a little bit of a decrease in the intensity of particles hitting the Earth since last night. They have a scale which I'm not very familiar with, so I'm sorry I don't totally understand, what the numbers mean. But I think we were at like an 8 or a 9 last night, which is about the top of the scale, and then I think it dropped down to about 6 or so today, which is still way above normal. I think that 1 is calm, and then 6 is, maybe you'll see an aurora, but probably not this far south.
Yeah,
we can talk about why that is if you want.
I'm sorry. What I was seeing is it's just, last night was the peak, and people are saying, when will we be able to see it? What I'm reading, and what was the website again? Was it Space Weather?
Yeah, it's the NOAA website, Space Weather Prediction Center.
Space Weather, and the website itself was it spaceweather.com?
It's www.swpc.noaa.gov.
Okay, swpc.noaa.gov. All right.
Yeah.
So, McKenna, I'm curious, in terms of what people are seeing. Now, first of all, have you ever seen the Northern Lights, having lived up north?
I have once, last year, during the really big geomagnetic storm we had in October of last year.
Now, how did this one relate to that one? How does it compare to that one?
Yeah, so they're both we are right now in a period of very high stellar activity. The sun is sort of at a peak. Its peak was actually last year, but it's still in a very high period of solar activity. And so because of that, lots of these different types of solar activity events are happening, right? This one in particular is a type of activity event called a coronal mass ejection, where the sun ejected part of its corona. And that wasn't the same thing as what happened last year, but it's a similar sort of thing. And it's happening a lot around, the last couple of years because we are at this solar peak, which is when the sun is the most active and has the most of these events and things going on.
And is that something that can be predicted, or is it literally you just see it happen and then you react accordingly?
So the activity cycle itself can be predicted, right? That's a cycle. It goes like this over an 11-year time period. Although we don't know exactly, right? Like it's not a perfect exact cycle. So we're not exactly sure when the highest peak is going to be or how high that highest peak is going to be. One of the cool things about these sort of activity events, though, we can't necessarily predict when they're going to happen on the surface of the sun, but they take time to get from the sun all the way to us here on the Earth. And so we can sort of watch them come. And that
How
gives
long?
us some
How long does it
prediction.
take to get from there? From the sun to the Earth?
I think what I was reading is it's somewhere between like 15 and 16 hours at the low end. So
Okay.
Yeah, that
less
sounds
than a day,
right.
up to several days.
And how is it
depending on how
tracked?
fast.
So we have a bunch of telescopes that are out orbiting the sun, right? There are a whole bunch of solar probes right now that are orbiting the sun and taking lots of measurements and things like that. So they can see when something like this happens, and then they can sort of watch it get further away from the sun and come towards us. And we have other probes and things that track space weather like that that are orbiting the Earth so that they can keep watch as it comes closer to us. So we have this whole, system of space probes in place to watch this kind of space weather. And, like Dr. McCormick was saying, the entire space weather agency that is dedicated to looking at this kind of stuff, because it can have really important effects here on Earth.
So bottom line, last night was more than likely the peak. I mean, we're still keeping our eyes on it for tonight, but are you, in your opinion, both of y'all, would you say that the odds of us seeing something in Florida are actually a little bit lower, or maybe a lot lower tonight than they were last night? Is that fair?
Yeah, I would say they're certainly lower tonight than they were last night, based on what I've seen. But you could still go out, take a look again, look to the north. If you're facing west, north is to your right. Wherever the sun went down, and take face to the right of that, and try taking a picture of the sky with your phone, like Dr. Wood said, because if you can, a lot of the more recent versions of phones will now have, especially with an iPhone, I think Android phones do this as well now. You can take a 2, 3, or even more second long exposure photograph, and that will really bring out the faint things which you might not even be able to see with your eyes. So there's still a chance tonight, but I agree that it's probably lower than it was last night.
Okay, well, I appreciate it. And McKenna, remind the folks one more time how they can come out and see the planetarium at MOSI.
Yeah, so the planetarium, we're open 7 days a week. We do 5 shows a day. They're on lots of fun astronomy topics, and not only astronomy, we do some other stuff in the planetarium too. But so you can come out and visit us anytime, and we'd love to have you.
Do you have an Aurora effect?
We do not have an Aurora.
So, if you didn't get a chance to see it, maybe you can see it there. Okay. Well, again, thank you so much, y'all, for coming on in this evening. Great information. We got about as sciencey as we could ever get here. And you guys have a great night again. Thank you so much for stopping by.
Thank you so much, Dennis.
All right. Take care. Bye-bye. All right. So that was awesome. And we're going to take a quick break, and we'll be back on the last segment with the forecast on how things are shaping up this weekend as Dennis Phillips Live continues. All right, we're on a break. That was 21 minutes. Thank you very much, guys. I really appreciate it. And was there anything else that you wanted to? Here, let me take you guys back so streamers can still see you. Was there anything else that we didn't cover that you wanted to mention?
I did want to mention one last thing.
Okay.
The reason we don't see the aurora so far south here in Florida typically is because usually those particles get funneled towards the magnetic pole, which is close to the north geographic pole. And so that's why you usually have to go pretty far north, like to Iceland or Greenland or someplace like that, if you really want to see a very nice aurora most of the time.
What causes them to be funneled toward the poles?
It has to do with the way that electric charges interact with the magnetic field. When they encounter a magnetic field, they tend to follow the lines of the magnetic field. They don't feel a force along the line. They feel a force that's perpendicular to the line. And so they spiral around the line. And so those lines or I should say the magnetic field lines go towards the pole. And so that's where the particles tend to travel. They tend to travel towards the North Magnetic Pole, which is close to the North Geographic Pole.
Okay.
And so that's why you typically have to go pretty far north.
Well, thanks again, guys. We're back in 5. Have a great night. I really appreciate your time.
All right. Thank you, Dennis.
Bye-bye. All right. Welcome back to Dennis Phillips Live. I think we have one more break, right? Remind me, guys. The viewers are my producers. I think we've hit 2 breaks. I think we need to hit another one quickly. But just a reminder, I was talking to Dr. McCormick. He also mentioned during the break, he's like, the reason trying to be funneled toward the North Pole, which is why areas like Iceland and areas to the north are far more likely to see it. And they will get far more spectacular auroras. I mean, I'm sure you've seen video and pictures of them at times. It's on my bucket list. I don't know if I'll ever make it, but certainly to go to areas that far north. But I guess the problem is, how do you time a vacation to know when you're going to actually be able to see something like that? I mean, I'm sure there's ways to do it, but it would certainly be a challenge. Hey, quickly, I want to jump into the forecast real quick. I know we have one more break that we have to hit, but temperatures right now, anywhere from the mid-40s to the upper 50s, so not nearly as cold as last night, but still for Florida, yeah, it's gotten cold. 46 in Crystal River, 49 in Brooksville after a morning low of 27. So the dew points are on the low side, as you would expect. The drier air gets colder. Dry air gets colder or hotter, and in this case, it is colder. There's a look at that 7-day. Highs of 76 on Thursday, 79 on Friday, lower 80s on Saturday, Sunday, low to mid 80s into the middle of next week. So we have one more break we got to hit. Pretty sure that was my third one. And we will be back in 90 seconds with a very quick heat lightning round. We'll see you in 90. Okay, so we are back. Now, I never saw this. Interesting. Y'all said that that there was a brief freeze for a period of time. I'm not seeing it. I'm showing a solid green on this, so it might have been Facebook. Not sure. But yeah, it says that Facebook frozen, freezing. So I'm seeing a lot of you guys just for about a 1-minute segment. But if whatever it did, it corrected itself because we're back to a solid green, streamer green. So anyway, but that was really awesome, wasn't it? I mean, and this was a last-minute thing because it literally crossed my mind. I was just thinking to myself, people might be interested into finding out why this is a thing and why we don't ever or hardly ever see it in the Bay Area. So I think we covered that pretty well. Thank you very much. Let's see, we are on the last. We have another 30 seconds left before our last break is over. And yeah, it said it randomly froze. Interesting. Just a quick glitch, Maria is saying. So, and we'll finish up here, and then we will call it a night. Ryan has a softball tournament right now. Let's see how she is doing. They were winning 8-4, and it is 14-5, and she's up. Oh, well, I got to watch that. Oh, wait a minute. We're back in 5 seconds. Oh, no, she's pitching. Oh, boy. That's a scary thing. All right, we're back. We are back. Last segment on Dennis Phillips Live. Again, this morning we hit 27 in Brooksville. We had low 30s in Citrus County, and now skies are clear. I've not seen, let me go on Twitter and see if anybody is reporting seeing the Northern Lights. Because usually, I'll be honest, more often than not, if you go on X/Twitter, you'll see breaking news on that faster than any other source in the world. Let me think. Northern Lights, I just looked. Someone's saying, it's sad I missed it last night. Nashville's showing some. There are some areas that are still seeing it, but I'm not seeing. New Jersey. Somebody's saying the best time is 9 p.m. to 3 a.m. I have no idea. That's what the Geophysical Institute of Alaska is saying. So, who knows? Anyway, that's it, guys. We're going to continue on streaming, but thanks for watching on broadcast. We'll be back tomorrow night on our next edition of Dennis Phillips Live. See you guys. Okay, so we are off broadcast, and we can come back streaming and bring Alex and McKenna back. You guys are back. I saw you were still there, so I'm like, yeah, what the heck?
I didn't know.
We'll continue. So hold on, I lost my IFB for a second. All right, there we go. So yeah, was there? Did you see or talk to anybody up north who had a chance to enjoy last night's, or see anything of it, or was it just kind of a spur of the moment kind of thing?
I did see some pretty spectacular pictures from a relative of mine in Kansas who saw it there, which was cool.
Yeah.
But and then some other folks I think also from the Northeast. But I didn't. I just saw the pictures you posted here in Tampa.
My daughter in Colorado saw some spectacular stuff, and she calls me at midnight on my way home, and she's like, "Dad, why didn't you tell me that there was a Aurora Borealis?" I go, "Kendall, you would ask Siri if it was going to rain and not even ask